Francis Turbine. But I want to give some basic knowledge on turbine. Turbine is a hydraulic machine which converts hydraulic energy to mechanical energy, and the mechanical energy finally converted into electrical energy. The turbines are basically classified into two types. One is impulse turbine and another one is reaction turbine. Impulse turbine are the turbine in which only kinetic energy is converted into mechanical work or mechanical energy. The example of impulse turbine is Pelton turbine, and the reaction turbine is the turbine in which the kinetic energy and pressure energy both are converted into mechanical work or mechanical energy. The example of reaction turbine are Kaplan turbine and Francis turbine. The three turbine, Pelton turbine and Kaplan turbine and Francis turbine are basically used depend upon the height of head, because the Pelton wheel or Pelton turbine is high head turbine. That means this turbine can be worked only in high head. The height of head is approximately 250 meter to 1000 meter, and the Francis turbine is a medium head turbine. That means this turbine can be performed at medium head. That height can be 40 meter to 600 meter. And the Kaplan turbine is also known as lower head turbine. That means this turbine can be performed easily at low head. In this turbine, the head height between 10 meter to 70 meter. Now I enters into our experiment. Our experiment is performance test of Francis turbine and find out its efficiency. For this experiment, we need a workable model of Francis turbine and a rotometer. Rotometer is needed for measure the RPM of turbine main-shaft, and a electric motor which is fitted with a centrifugal pump to supply the water to the turbine. The Francis turbine can gives us the power of 100 kilowatt to 100 megawatt, and this turbine can rotate in RPM 68 to 1500. Now I going to discuss on Francis turbine. Francis turbine is a mixed flow reaction turbine. I say that mixed flow reaction turbine. Mixed flow reaction turbine means here the waters enter into the turbine at radial direction and out axially. Therefore, this turbine is known as mixed flow turbine, or we call mixed flow turbine. Okay. Now we introduce the all parts of turbine. First of all, this part is known as scroll casing, then this part is known as guide vanes, and this part is known as inlet of turbine, and this is runner, this is vanes, this is main shaft, and this is draft tube. Okay, The scroll casing is a spherical in shape and whose cross-sectional area gradually decrease, and where the water is entered through the penstock. The next part is guide vanes. Guide vanes is the part which is situated inside the scroll casing and which control the flow of water. Then next part is water inlet. After passing the guide vanes, waters are entered to the runner through the inlet. Then our next part is runner. Runner is main parts of this turbine which hold the all vanes of turbine, and all vanes are sequentially fitted on the runner, and runner is attached with the main shaft. When the runner is being to rotate, the main shaft also be rotated. The next part is main shaft. Main shaft which is attached with the runner, and this is used to transmit power from runner to another place or generator. When the runner rotates, then we get mechanical energy, and this mechanical energy is transferred to the generator with the help of main shaft. Okay. Then next part is vanes. In this Francis turbine, the all curved vanes are sequentially fitted on the runner, like as this figure. And this is runner, and these are vanes which is fitted with the runner, and this is main shaft which is fixed with the runner, and these are the guide vanes, and these are the guide vanes. The next part is draft tube. Draft tube is a tube whose cross-sectional area gradually increase, like this. The mechanism of draft tube is to decrease the velocity of discharge water. Therefore, the loss of kinetic energy is less. So, the sum of pressure energy is converted into mechanical work. Therefore, the efficiency of turbine can be grow or more. Now I am going to discuss on the working of Francis turbine, or how the Francis work can be worked. First of all, the water enters into the scroll casing with the help of penstock. After that, the water flows through the guide vanes and enters into the runner and strike the vanes with the high velocity. After strike the vanes, leaves the water with a low velocity. Therefore, the runner can be start to rotate. So, main shaft also start to rotate, and after that the discharge water is flow to the tail race through the draft tube, and in this draft tube the discharge water velocity also decreases and the loss of kinetic energy less. In this way, a Francis turbine can be worked. Now I want to introduce with this Francis turbine model so that you can understand easily and better. This is a model of Francis turbine. This is outlet, this is inlet, and these are the vanes, and these black colored parts are guide vanes, and this is main set, and the all guide vanes can be controlled with these parts or this screw. Okay, in this turbine water enters into the turbine radially and flow to the vanes with the help of guide vanes, and after that the water discharged through axially. Okay, we need to calculate the efficiency of Francis turbine. Therefore we collect some data. The data are RPM of main shaft and pressure gauge reading at different loading condition. We take the 4 to 5 data at different loading condition and then calculate the efficiency of Francis turbine. Therefore we need to go the workable model of Francis turbine and measure this all data correctly, then we calculate easily. This is a workable model of Francis turbine. Now I am going to introduce all parts of Francis turbine. Here two parts, one is mechanical parts and another one is electrical parts. These parts are electrical parts, and these all parts are mechanical parts. This is 3-phase MCB, and this is indicator of 3-phase, and this is starter switch and this is stop switch. Which is in 5 horse, and this 3-phase motor is connected with a centrifugal pump. Then this is suction pipe and this is delivery pipe. This is also known as penstock of this turbine. Then this is Francis turbine casing, and the turbine vanes and blade are situated inside the casing. This is draft tube which is connected with the discharge of turbine, and this is the adjustable screw which can be adjust the angle of guide vanes, and this is the drum of Francis turbine. The dimension of this drum is 292 mm in diameter, and this is the weight balance which is used to measure the weight, and this is a pressure gauge which is used for measure the pressure, and this is the storage and tail race of the turbine, and this is the delivery pipe to fill the water at the turbine sump or tail race, and this is the discharge pipe which is used for discharge the water from the reservoir or storage. Now I am going to discuss about the procedure of this experiment. First of all, we need to close this valve to stop the discharged water. Then fill the water at least 75% to 80%. Then on the electric motor with this starter switch. Then here set the load is 0, and after that note down the RPM of drum and the pressure gauge reading with the different load condition. The RPM can be measured with this rotometer. So I start the turbine. Now its weight is 0 and the pressure was reading is 1.1. We fix the load. Now I fix the load 500 grams. And I see that the pressure was reading is 1 and the rotometer reading is 771 and 820 and load it. After that I load 180. After that, I close at 1.56 and note down the pressure reading and the RPM of the drum with the rotometer. After that, we also give the load and note down the pressure reading and the RPM of the drum. All data properly, and you need to put this observation table. First one is serial number and N for speed of the main shaft in RPM. Then next one is P. P for pressure gauge reading. Then W1 is applied load. Which load can we apply during this experimental time? Then W2 is the dead weight, which is always 0. Then we need to calculate T and output. So we put the all values. First we put the N 980 and then the pressure gauge reading was 1.1 kg per centimeter square, and then the load we applied on the turbine is 0, and when we load the half kg or 0.5 kg, then we found the pressure gauge reading is 1 and the RPM of main shaft is 790. After that we apply the load of 1 kg. Then the pressure gauge reading was 0.9 kg per centimeter square and got the RPM was 683. After that again we load. After that again we give load 1.5 kg. Then we got the pressure gauge reading 0.8 and the RPM was 575. After applying 1.5 kg, again we give the load of 2 kg. Then we got the pressure gauge reading was 0.7 and the RPM 492. Okay. Now we calculate the T. The formula T means torque. The formula of T equal to W plus W1 minus W2 into G into R. Here the W means weight of the drum, that is previously given. The W value of W equal to weight of drum. Equal to 15 kg, and the W1 we find out various loading condition. W1 is applied load, W2 dead weight. equal to 0, and G for gravitational constant, G for gravitational constant. The value of G equal to 9.81, and R is radius of drum, which is given. The radius of drum equal to 110 mm. Equal to 0.11 meter. So now we can calculate easily the value of T. T equal to W equal to 15 plus W.0 plus W minus 0 into G into R equal to 9.81 and 0.11. So we can get the value $16.19. I put it.
Similarly, we calculate the all value of T at different loading condition.
And we put the all value of T, that is 17.16.73, 17.27, 17.81, and finally 18.38. Now we need to calculate output value and input value. Now we need to calculate input power and output power. The formula of input power equal to motor power into motor efficiency. So motor power is equal to, our motor is 5 Hertz, so 5 into, we know that 1 horsepower is equal to 746. So multiply with 5. 746 into efficiency of motor is 60%. Now we calculate easily the value of input power of turbine equal to we can write down this 5 into 746 into 60 divided by 100 equal to 5 into 3 is watts. Also we write down 2.238 kilowatts. Okay, now we calculate the output value or output power. Now we calculate the output power of turbine. Input power equal to 2238 or 2.3238 kilowatt watts. The formula of output power equal to 2 pi N T by 60 equal to 2 into 5 into n. Here n equal to 980. Here n equal to 980. So we put it and the t equal to 16.19. So we put this value and calculate it. Finally we got the value equal to this is output value. So we put it 16.150 and similarly we put the all value. Zero 5 12 35.21 1072.41 then 900 Okay, and the summation of output power equal to summation of output power equal to, all are added, all value are added, so we can get 6 to 98.09, and this is also watt. Okay, and the mean value of output power equal to, it divided by 5, so we get the 5 reading, so we divide it with 5, then we get the value is 1259 watts. Okay, equal to 1.259 kilowatt. Now we can easily calculate efficiency of turbine. The efficiency of turbine equal to output by input. Here the output equal to 1.1259 divided by 2238. That means 1259 divided by 2238. Here the output power is 1.259 and input power is 2.238. This is the output of the turbine and input power of the turbine. From this we calculate the value is 0.56. So we can write the efficiency of turbine equal to 56, because we need to multiply 100 with this value. So we can get the efficiency of turbine equal to 56%. How can get? Multiply with 100. Okay, this is our efficiency of turbine, Francis turbine.